Okay, sorry everyone. I had a temporary disruption in my network, so I got disconnected. We will be resuming the class. Sorry for the disruption. Okay. My screen is visible.
Yes, sir.
Yes. Okay. So where were we? We were in the prerequisites. So for the first question, I will give you every question one by one on the screen, and then you will be given 2 minutes, 3 minutes, 5 minutes, depending on the length of the problem, and then you can report back with the answer. And after that, I will give you the solution. I don't want you to give you the solution right away because you need to practice. The first part is the even component of the signal xt is equal to rectangular t by t. So here this pi means rectangular box function. Okay, so you are familiar with what is a rectangular or box function, right? So this is the box function. So the even component of this box function is, so please start solving. You will get 2 minutes. Yes. So anyone has any answers? Okay. You can open your mic and speak if you want. You don't have to give messages. So B and A. These are the two options. Okay. So anyone else? Pratik says B. Srinivas says A. Anyone else? Okay. So the correct answer will be B. Option B. B for Bombay. So what is the how to find the even component? So the even component is something which, how do you find something's even component? Like if xt is given, you take the x of minus t and you divide by 2. So if xt is the sum of even and odd parts, xt is the sum of even and odd parts, then x even minus t will be x et and x odd minus t will be minus x odd by 2. So this will be this will be x even t. So this is x even. Okay. So here we can similarly take this logic. So it is rectangular t by t. So it is basically from minus t by 2 to t by 2. It is 1. Elsewhere it is 0. So this is the function. So if you take the negative of it, so what was in t by 2 will come at minus t by 2, right? It will just get mirrored along the y-axis, but it is symmetrical along the y-axis. So mirroring it will result in the same function. So xt is pi t by t, right? And what is x of minus t? X of minus t is again pi t by t. So what will be x even t? X even t will simply be the pi t by t plus pi t by t whole divided by 2. So it's nothing but pi t by t. So the correct answer is option B. B for Bombay. Okay. So here it is, option B. Okay. Next. Um, hmm. Next is Next question is the impulse response of a linear time invariant system. Yt is equal to the integration up to t of x tau d tau is delta t, which is the impulse function. This is the impulse function. And then there is ut. This is impulse. This is step. Ut is step. T is simply time. And none of the above. So I'm just writing none of the above here. Now tell me, what will be the answer? You have 2 minutes. What is the impulse response of this system? Where this is yt is equal to t minus infinity x tau d tau. T2 minus infinity x tau d tau. Okay, you have 2 minutes. If you have an answer, you can open your mic and talk. Okay. Pratik, your answer is B, right? B for Bombay.
Yes.
Okay. Okay. Anyone else? Srinivas,
Sir,
do you have the answer?
U of T, sir, U of T.
Step function.
B.
It is
Yes, sir, sir.
option B. Okay. And the correct answer is option B. So, what is happening is this is the impulse response. So, the impulse response you can see, the impulse response is, what is the impulse response? It is the HT convolution of XT, right? So, YT is equal to YT is equal to now what is the impulse response? Impulse response is YT when XT is delta tau, delta t, right? So it is YT at delta t. HT is just you put delta. This is impulse response. And this, the integration of impulse, we know from general knowledge is step function, right? So the answer is step function. Okay, so the correct answer is option B. Okay, next. The uh, step response of the linear time invariant system. Okay, so again you are given a linear LTI system. YT is equal to this integration x tau d tau. So now you have been asked of the step response, not the impulse response. So what will be the response when the input is impulse, not step? Input is step, not impulse. So try. You again have 2 minutes. Just same question, same setup, but
C.
your C. Can you tell me why?
Uh, Here we'll be taking the x of t as u of t. So as u of t existing will exist from 0 to t. So integrating u of t for in the interval 0 to t will result answer as t.
Yes, right. Very good. So the correct answer is T. So here I think I am not giving any further explanation. So here x you put xt as u tau, and u tau exists only in 0 to t. It will not exist from minus infinity to 0. So 0 to t it will exist. You modify the limit to 0 to t. So 0 to t ut dt is t. That's it. Okay. Now this is a true or false question. The system given by this yt is equal to x minus t minus 3 plus x3 minus t is linear. True or false? This is true or false? True. Okay. I'll wait 1 more minute. Let's see what everyone else says. Okay. So the here the Pratik has said the answer is true. Let's see. So the correct answer is true. So what we have to do is we just have to check whether this is linear or not. Okay. So how do we check that? We simply put the definition of linearity and follow from there. So what is the definition of linearity? Linearity is must follow two things. That is and C of rather C H of system H is linear. Sorry, I will rewrite. A system H is linear if yt is equal to h of like cxt will give c of h of xt and y1t plus y2t should be h of x1t plus x2t. So you have to follow these definitions. So one is called homogeneity and one is called additivity. So the first principle is homogeneity. Here homogeneity you can easily say that homogeneity will be followed as yt is equal to c of x minus t minus 3 like y1t is equal to c of x minus t minus 3 plus c of x3 minus t. So we are just multiplying c with xt and then we are shifting them in time. That is what we are doing. We can take c common. So this is x of minus t minus 3 plus x of 3 minus t. So this is just c of yt. So when we scale the input by c, the output also gets scaled by c. So it is homogeneous. Next is additivity. Next is additivity. For additivity, you will just do c of x minus t minus 3, x1 rather. Let's take one sample of the input as c, let's leave c. Let's take one sample of input as x1 and another sample as x2. So this is y1 and this is y2. Now, independently, what will be yt? It is y1t plus y2t. Let's define. So it will just be the sum of these two. x1 dot dot plus x1 plus x2 minus t minus 3 plus x2 3 minus t. So this is also additive. So additive and homogeneous. So this and this together make this system. Yt is equal to x minus t minus 3 plus x t minus 3 is linear system. Is linear. So true. So this solves our problem. It is true. Next, of course, one follows the other. If you have been asked to check the linearity, you will always be asked to check the time invariance. So, can you check the time invariance in 2 minutes? Oh, uh, Acha, everyone, please, when you have an answer, please open your mic and interact because this is supposed to be an interactive session. So it will help me and you if you interact with me. Okay? So please open your mic and state the answer rather than writing in chat box because I have to show an interactive session. Right? So please open your mic and state the answer. Pratik? Pratik?
Yes, sir.
Please state the answer. Please open your mic and loud and in loud and clear voice state the answer because I want to have an interactive session. Okay,
Mm,
this is for
yes.
everyone. The answer for 5 is true or false?
True.
True. Okay. So why is it true?
Mm, because because there it is input. Its input is T naught, and the input becomes x of t minus t naught,
Okay.
and then we y1 of t in y1 of t. First,
Yes.
uh, first sir, x of minus p x of minus t minus t naught.
So what you mean to say is basically one time we will put yt minus t naught and
Uh,
another time we will do x of t minus t naught. Okay. So one time we
yes.
will universally replace in the yt minus t naught. That is, we will universally replace t with t naught. And another time we will only replace t with t minus t naught inside the x argument.
Yes. Yes.
So that is what we do. So one time we are giving a shifted input signal, and another time we are shifting the time frame of the system. So, giving a shifted input signal to a system at present time and giving a present signal to a shifted system should result in the same output. That is what time invariance means. Now a very shortcut for you all, that if you want to check whether something is time invariant or not in a very simple fashion, what you can do is you check whether all the function expressions, all the expressions involving time are within x or not. If all of them are within x, then it is time invariant. But if all of them are outside x, or some of them are, not all of them, of course, all of them cannot be, some of them are outside x, then it is time variant. That's why yt is equal to xt plus 3. This will be time invariant, TIV. But yt is equal to txt plus 3. This is time variant. Why? Because there is a t outside. So this is one way of easily testing whether something is time invariant or not. If all the time expressions, all the item, what to say, all the instances of the time variable is within this input signal, then it is time invariant, or else it is time invariant. So here we see that all the expressions of time, two are there, are both inside the input signal. So it is time invariant. But if you want to do it formally, of course, this is a shortcut. So if you want to do it formally, then yt is equal to x minus t minus 3 plus x3 minus t. Now, now, yes. So here first, let's do y t minus t. So here just we are replacing t with t minus t naught. So and another time I will do x of, I will replace xt with x of t minus t naught. So mhm. Now these two will look identical. This is replacing t by t minus t, and this is replacing xt by replacing xt by x t minus t naught. Now these two will lead to the same expression. So yt is, so this system is rather not yt, system is time invariant. Now this will look very trivial, because you see, like you will feel like we have done the same thing again and twice. So I will give you a counter example where the signal is time invariant, where you can clearly see the distinction. So here you see yt is equal to t xt minus 3. Here first do replace t by t naught on both sides. That is, you are shifting the entire system. Replace t by t minus t naught. So here you will do yt minus t naught is equal to t minus t naught xt minus t naught minus 3. Next, you will shift the signal only. So replace xt by xt minus t. Here you are shifting the signal only. You are not shifting the time. So here you will see that y1t, let's say, that is the output to the shifted signal, is t of xt minus t into xt minus t naught minus 3. Here you see this t remains unaffected. Why? Because you are only shifting the signal. So the system response remains unaffected. So y1t is not equal to yt minus t naught. Therefore, it is time variant. So the system response will depend on what time it is, and it will not be invariant to time shift. Okay. So the correct answer is here true. It is both linear and time invariant. Okay. Now, okay, the system given by yt equal to x minus t minus 3 plus x3 minus t is the system given by yt equal to x minus t minus 3 plus x3 minus t, that is the same system as previous, is stable. So how do you check stability? The correct answer is true. So how do you check stability? So here it is said that the signal is stable. The system is stable. Now system stable means when you give an infinitely large input. So you are increasing the input. So when you give an input of infinite magnitude, if your response also goes to infinity, that means your system is not stable. As whereas when you give an infinitely large input, if your system gives a stable finite output, that means it is stable. 1 minute. না না, আমি ক্লাস নিচ্ছি আসলে এখন কি হয়েছে কি বলবো বলো, তোমার ট্রিমারে ফিট হলে কিনবে, না হলে কিনবে না। কি কি? আর নিপ্পো তো ভালো হয়, হ্যাঁ। ফিট হলে কিনো, না তো কিনো না। হ্যাঁ হ্যাঁ হ্যাঁ, ফিট হলে কিনো। আমি জানি না তোমার ওটা ট্রিমারটা ট্রিপল এ না ডাবল এ। হ্যাঁ হ্যাঁ হ্যাঁ। Okay, so here whether the system is stable or not, we will check. So the if signal is bounded, then your systems should be bounded. Rather, I have defined it like somewhat erroneously. Sorry. So what stability means that if your input is bounded, your output has to be bounded. Okay. If your input goes unbounded, goes to infinity, then it might go to infinity. That is another question. But if your system is bounded, if your input is bounded, your output should be bounded. So that is called BIBO or BIBO stability. Bounded input, bounded output. BIBO stability. So how to check the BIBO stability of this system? To check the BIBO stability, you consider what happens when xt, or rather the magnitude of xt, the sign doesn't matter here, the magnitude of xt is bounded. So yt is xt minus x, I think minus t minus 3 plus x of 3 minus t, this kind of a system was there. So if mod of xt is less than b, where b is finite, now consider these two terms, this one and this one. These two both are just shifted versions of xt. Now shifting has no effect on magnitude whatsoever. So mod xt is equal to mod xt minus 3 minus t minus 3, whatever that is equal to mod of x3 minus t. So mod x, whether they're equal or not, we can stay with guarantee that if xt is bounded, then they will be bounded. So if both of them are bounded, then yt is less than 2b. Now which is also finite. If b is finite, then 2b is also finite. So rather mod yt. So yt is bounded if xt is bounded. This is called Bevo stability. So if you give a finite input, you will get a finite response. This guarantee is called a stable system. So the correct answer is option A. Now we have to go to causality. So what do you mean by a causal signal? Anyone?
which
What
is
is
different from present
yes,
and past values only, sir.
yes. Or if you give me a more mathematical definition, so basically what happens is
Less
that
than equal to t.
what?
Less than or equal to t. If the system is defined for less than or equal to t. Defined for, sorry.
Yes. So what is means like here mostly if you take an arbitrary reference, usually we take it as t equal to 0, but it can be different for your case. But if you take a reference point, all points to the left should be 0. So the signal should be left to the from that reference point, whatever is in the left, that should be 0. So you, in other words, in negative time, your signal should be 0. It should only be in the positive time. Okay. So that is for signal. Now for system, causality means that it should not depend like on the future values. So future value means if y of 0 is dependent on x of minus 3, then that is not causal. That means it depends on the future. It depends on what, like what will happen 3 steps ahead. You have to advance the signal to know the result. That is not feasible. So here in this system, x minus t minus 3 plus x3 minus t. Here you can prove non-causality simply by putting t equal to 0. If you put t equal to 0, y0 is equal to x of minus 3 plus x of 3. So this part is fine. Y0 is equal to x of 3 is fine. But y0 is equal to x of minus 3 is not fine. So it depends on the, rather I might be saying in the opposite. Yeah, so this part is not fine. So it is where it depends on the future values. So y0 you can see depends on the future values. So this will not be Rather, I am saying opposite. Y0 is equal to x of minus 3 plus x of 3. So for 0, y0, x of 3 is future, not x of minus 3. So x of 3 is future. So this one is wrong. This one should not be there. If this one is there, then it is non-Gaussian. Okay. Now, the system given by log of xt minus 3 plus x3 minus t is linear. True or false? Solve. I'll give you 2 minutes. Question number 8. Please solve question number 8. And if you have the answer, do not give in the chat box. Please open your mic and tell the answer out loud.
Sir, because of logarithmic function, it is not linear.
Yes, true. And have you could you show it in pen and paper? It is true. Like if you are asked at MCQ, you are correct. But if you want to get a formal proof, so yt is equal to log xt minus 3 plus x3 minus t. Xt minus 3 plus x3 minus t. 1 second. Yeah. So y is equal to log xt minus 3 plus 3 minus t. X3 minus t. Just replace xt by cxt. So here you have yt is equal to log cxt minus 3 plus x3 minus t. C x3 minus t. So here you can see that this is not simply equal to like this. Let's say this is y1t. This is not simply equal to like c. You cannot take the c outside, right? This is log c plus log xt minus 3 plus cx3 minus t. Now, this is not equal to simply scaling by c. So this is not equal to c of log xt minus 3 plus x3 minus t. So this function, this system violates the principle of homogeneity. So it is not linear. It is not linear. Now there are two principles. One is homogeneity and one is additivity. And both simultaneously need to be satisfied for this system to be linear. And we have shown homogeneity does not hold. So we do not need to prove linearity because we have shown homogeneity does not hold. That is sufficient. So it is non-linear. Correct answer is B. Now, time invariance. Can you just by looking at the signal, by the trick I have taught you, Can you just by looking at the signal say whether it is time invariant or not? Anyone?
Time invariant according to the logic book. Both are lying inside X.
Yes. Both are lying inside X, so it is time invariant. But here I think this assignment is like in a bit, yeah, xt minus t naught. I don't know why they have given variant. I will check with the guy who has made it. Okay, so let's leave that. The system given by yt is equal to log xt minus
Sir,
again.
one small doubt, sir.
Yeah.
Based on that particular logic, that means logarithmic function, will the logic whatever we have discussed, will it vary?
Huh.
Because earlier log
No.
was not there.
No, the thing is, as long as the t is within x, the log should not affect it.
Okay, okay,
Because however way you shift the t, it remains within that log. But if the t was outside x, then it will get affected by the
okay, okay, okay.
log. Okay. Next is stability. Stability, see, if xt is bounded, if xt is less than b, finite, then xt minus 3 is also finite. That is guaranteed. x3 minus t, xt minus 3, both are finite if xt is finite because they are just shifted variables of xt. But and another thing is it guaranteed that if your argument is finite, you will have uh, like finite log? So xt minus 3 is finite. This is finite. Just the xt minus 3, just this part. But is this finite? Is log xt minus 3 finite? What happens if we have log 0.01? That is minus 2. 0.001. This is minus 4. Right? So if you go smaller and smaller and smaller, it is a very bounded quantity. So limit x tends to 0 log x. So here we can of course say x is bounded. It's just very small, but it is bounded. It is not going to infinity or minus infinity. It is going to 0, so it is bounded. But log x is minus infinity. So even though x is bounded, x is going where? X is going to 0, so it is bounded. But log x is going to minus infinity, so it is unbounded. So if you have very small signal value, this will go to minus infinity. So the whole system will become stable. So here it is not Bibo stable, false. Okay. Is the logic clear to everyone?
Yes, sir.
Yeah. Okay. Someone wants to join. Someone else. Now, again causality. We have to check for causality for the same signal. So here, if you put 0, just like the previous one, this will depend on x minus 3 and x3. Now, sitting at time t equal to 0, it is not possible to predict what will happen at time t equal to 3. So, getting your y0 from x3 is not possible. So, this is option B is, so it is false. It is not causal. It is non-causal. Okay? Because you need to depend on future values. Depending on future values makes your system non-causal. A signal can always be written as a sum of an even signal and odd signal. Is this true or is this false? So, yeah, just you have to rewrite the definition. That will give you the answer.
True.
Yes, it is true. So, here just you have to rewrite the answer. Like xt you can write it as some xet plus xot by 2, let's see, rather xet xot. So here, what is, if this is true, we have to verify whether this is true or not. Okay, so what we can do is we will write xt as xt plus x of minus t plus x of t minus x of minus t, and just to normalize, whole divided by 2. We can write like this. Now, what is this part? This part is basically the definition of an even part of the signal. This is xet. And what is this part? This part is by definition the odd part of the signal. We did not have any specific comment about the nature of the signal, yet we came at two specific parts of a signal, one which is always even, one which is always odd. So we can say that xt can always be composed by an even and an odd signal, provided it is real. If it is complex value, then it is not possible because the even odd concept does not exist. But for a real valued signal, it is true. Now the period of cos 2 pi 200t plus sine 2 pi 250t. Try this for 2 minutes. So 1 more minute. Anyone got the answer? Okay, I'll solve it for you. So let's forget about this and take a very small example. We take one sinusoid. Oh, come on, man. Who wants to join this thing? Okay. So we will take a very small example, that one is a sinusoid which has a period of 2. So we have one sinusoid which has a period of 2. So 2 pi by 2 pi t by t. So here t is 2. So if it has a period of 2, that means it will repeat every 2 seconds. So it will repeat at 2, then at 4, then at 6. Now, if you have another which is sine 2 pi t by 3, so it will repeat at 3, then it will again repeat at 6. So the thing is, if you add them, then the signal, overall signal yt is equal to, this will repeat when both of them are repeating. Now this will repeat at 2, 4, 6, 8, 10. This will repeat at 3, 6, 9, and so on. So when do they truly repeat? When do both of them repeat? So that yt repeats. When do both of them repeat? At 6. When will the next both of them will repeat? 12. Because 12, 12. Again common. But for time period, only the lowest matters. What is the definition of time period? The lowest value of time at which the signal repeats itself. So 6. So here the answer is 6. Why? Because it is the lowest common multiple. So simply the sum of two sinusoids will have a period which is the LCM of the two periods. This is a very well known formula, but I still wanted to give you a derivation. Now, here you have sine, one part is 2 pi into 200t. Okay, so what is the time period? The time period is 1 by 200, and another is cos 2 by 250t. Sine cos here doesn't matter. Sinusoid is what matters. Oh, come on, man. So it is the LCM of 1 by 200 and 1 by 250. Now here 2 pi, I think of 200, 200, F is 200, 1 by 200, 1 by 250. So here 1 by 200, how many times will you multiply? 1 by 200 you will multiply by 1. So they have given it as this this is slightly wrong because 200 is not period. 200 is the frequency f, because cos 2 pi ft sin 2 pi ft. So they have simply said that the period is the LCM of 200 and 250, but 200 and 250 are frequencies, as you can see, and the time period is the LCM of the time periods, not the LCM of the frequencies. So actually LCM of this and this, like if you, what is the common multiple? So if you reduce them, if you multiply them by say probably what, 5 maybe. So basically what it
Answer
is,
is answer is
yeah,
approximately we are getting 1/100, sir. That's what I was checking in the answers.
yes, HCF will be 200 and this will basically become HCF of 200 and 250. So I think this should be 50 T by 4 and I think 50. I think it should be 50 or 100. Hmm, let me check 1 minute. The answer is wrong. Yeah. Hmm, let me check 1 minute, okay? Because the answer is wrong here. Yes. So it will be actually 1 by, yeah. So here LCM of the reciprocals, this is what I wanted to confirm. The LCM of reciprocals becomes the HCF or GCD. Huh. So GCD of this HCF or GCD of 200 and 250. So what is the HCF? What is the common factor? The highest that goes to both, 50, right? After that anything won't go. So 50 is the highest. So the answer will be 50. So here the answer will be rather not 50, 1 by 50, 1 by 8. So it will be 1 by 50. The time period will be 1 by 50. So basically LCM of 1 by A and 1 by B is nothing but 1 by HCF of A and B. HCF or GCD, however you say. So here the GCD of 200 and 250 is 50. So the correct answer is 1 by 50, not 1000. What is given here? So it is 1 by 50. The correct answer is option E, 1 by 50. Okay. Next, what is, if xt is rectangular t, then t by t, then what is the convolution of rectangular t by t with itself? That is the question. What is the convolution of xt by with itself? So let's try. First you try. This is rectangular. Okay, so this means this is this minus t by 2 to t by 2. It is 1, elsewhere it is, this is 1, elsewhere it is 0. this is your xt. So convolve it with itself. You can do it mathematically, you can do it graphically, your choice. But try. For this you will get, how much do you need? 3 minutes. If you want, you can ask for more, but try to do this on your own. You can do it graphically or you can do it mathematically. Your wish. Anyone there? Mm, take 2 more minutes, then we'll try. So I'll start solving. If any one of you have reached the solution, you can tell me. Okay, this will be a little bit tedious, so follow me. So here we have to convolute rectangular t by t with itself. Now rectangular t by t only exists between t by minus t by 2 to t by 2. Okay, that is the definition. Now what does this mean? This means minus infinity to infinity rectangular tau by t rectangular tau minus t by t d tau, right? Now sorry, this will be t minus tau, tau minus t minus tau. Now tau, when does rectangular tau by t exist? It exists between capital T by 2 minus to capital T by 2 plus. So minus T by 2 to plus T by 2. And where does t minus tau exist for this rectangular function? Again, it exists in the same limits t by 2 to minus t by 2. So here we have 1. This is 1. Let's forget this. Now this will imply that t minus capital T by 2 is less than minus tau is less than capital T by 2 t plus. So we can just invert the signs. So tau. Now since you are inverting, so this one will come this side, and this will go to the other side. So t minus t by 2 will become minus t plus t by 2. Now what will be the overlap region? In only the overlap region will the convolution exist, right? Outside of this cone overlap region of 1 and 2. So here we have 1 and here we have 2. Take a look at the equations 1 and 2. So outside of this, rather inequations. So outside of these regions defined by the inequations 1 and 2, the convolution will simply be 0, because any one of them will be 0, and if one of them is 0, the entire convolution is 0. So effectively tau is defined between the minimum, rather not the minimum, the maximum, because we have to find the intersection area. So the maximum of minus t by 2 and minus t by 2, and in this side it will be the minimum of t by 2 and minus t plus t by 2. So this is the limit of tau. So here we will be writing this as, say, m1 and this as m2. So m1 is less than tau is less than m2. Now since tau only exists between m1 and m2, we have to here it is. So we will be integrating this convolution between m1 and m2, and in this convolution what will be the, this will be just d top, because both of them will be 1. They can only take two values, 1 and 0. So if they are not 0, they will be 1. So it will just be m2 minus m. Now here m1 and m2, here m2 is defined as minimum of t by 2 and minus t by 2 and minus t plus t by 2. This is, I think, m1, t by 2 and minus t plus t by 2, and m2 is defined as, sorry, this is m2, m1 is defined as max of minus t by 2 minus t by 2. Now here, if mod t is less than t, then if it is less than t, then you will see that this will be minus minimum of, you will have to find like here you can rather, this is rather confusing to explain. So what you will get is, if you simplify this into regions, what you will get is, you will get only, in some places you will get t minus t plus t by 2, and say plus t. This can be one possibility, right? This can be one possibility. So if we take this one, say this one is bigger. So when is this one bigger? When will minus t plus t by 2 be chosen? When minus t plus t by 2 is less than t by 2. So minus t is less than 0, t is greater than 0. So for positive t, this will be chosen. Okay. And for positive t, which one will be chosen from here? Here you see, this one is minus t by 2. And here you are making, since t is positive, you are making minus t by 2 even more negative. So something like, means minus t by 2 and minus 2 minus t by 2. So which is more negative? This is more negative, right? So this one will be chosen. Minus t by 2 will be chosen. Because you are adding something negative to an already negative number. So you are making it even smaller. So of course minus t by 2 will be chosen. So if t is positive and within t by 2, then this, within t rather, this will be chosen. So this is the t minus t plus t by 2 plus t by 2, that is minus t plus t, capital T, minus small t plus capital T. So this is a falling line. And if you take the x intercept, y intercept, it will fall like this, right? One. Similarly, if you take one situation where it is t by 2 minus of minus t by 2 minus t. So this will become t plus t by 2. So this will be like this. T plus t by, not sorry, small t plus capital T. Two t by 2's will get added, so it will become small t plus capital T. So like this. So this is small t plus capital T, and this is minus t plus capital T. Now, if none of them get chosen, like this one gets chosen and this one gets chosen, that is not possible. You can see there will be no overlap. So these two won't get chosen. Similarly, these two won't get chosen, right? Because that will give you just capital T constant, and that will not happen. You will see if this one gets chosen, this one will get chosen, and if this one gets chosen, this one will get chosen. So two pairs out of these four pairs, four possible pairs are there, right? So if only two pairs are possible, the rest two pairs won't be possible. And apart from that, in elsewhere there is non-overlapping region, so it's outside of M2 and M1, so it is 0. So it will become a triangle. Okay, so it will become a triangle, and sorry, the intercept, and now what will be this intercept? So y is equal to minus t plus t. What will be the intercept? You take y plus t equal to capital T, you divide by capital T, y by capital T plus small t by capital T is equal to 1. This is classic x intercept y intercept form, right? X by a plus y by b. So both intercepts will be capital T, and here also you can see both intercepts will be, one will be minus t and another will be capital T. So finally, the convolution of rectangular function with itself gives you a triangular function. It will give you a triangular function shaped like this. So this will be T triangular T by T. So that will be the answer. It was a bit marathon. I hope everyone followed. So it will be T triangular T by T. Okay. Next, the output of a linear time invariant system with impulse response ht and its Fourier transform h omega, and input is xt is equal to e to the power minus j omega t. So there is a system with impulse response ht and an input xt equal to e to the power minus j omega t. So what will be the output? This is fairly straightforward. So there is ht and there is e to the power minus j omega t. What will be the output? Try. You can use Fourier transform also if you want. You can do it in the time domain or do it in the Fourier domain, whatever suits you. Oh, you have to do it in the Fourier domain rather. Okay. So let's take a time domain convolution. E to the power minus j omega t and ht. Let's do a convolution. what will be the convolution? H tau e to the power, I think minus j omega t, is it? Minus j omega t. So e to the power, yes. So e to the power minus j omega t minus tau t tau. So what will be the answer? It will go from infinity to, wait a minute. I think this is wrong. The answer is wrong. Anyways, let's check. Okay, so here we will just take e to the power minus j omega t common. So this will become h tau e to the power minus j omega, rather not minus, plus j omega tau t tau. Okay, yeah. So it's not wrong. So e to the power minus j omega t into h omega. This is by definition the Fourier transform of ht, right? So it will be h omega, but I think this one has a minus, if I'm not wrong. So this will actually be e to the power minus j of minus omega t. So I think this will be h of minus omega. So I think it will be h minus omega e to the power minus j omega t, if I'm not wrong. So let's see. Yes, h of minus omega e to the power minus j. Is it clear? You just take e to the power j omega t out, and then you have the definition of Fourier transform at your hands. Now, a continuous LTI system with input xt and output yt yields the following input output pair. So if you give e to the power j2t, it gives e to the power j5t, and if you get e to the power minus j2t, you will get e to the power minus j5t. So what is the input when you give cos 2t? Try this one. You don't need to do integration or anything here. No integration or no convolution. Take 3 minutes. Think how you will solve. One hint is you don't need integration or convolution. Srinivas?
Sir, is it cos 5t?
Yes. How is it? Cos 5t.
Mm, if you are expanding cos term in the exponential, it can be written as e power jt plus e power minus jt by 2, where
Yes.
already one term is given as positive and exponential another term is given as negative. Added by
Yes.
2 will result as x of t,
Okay.
e power
Then
jt.
then how
Similarly,
are we getting cos 5t?
output side also the same operation, e power,
Okay. And how
same
can we
logic.
do, like, how are we sure that doing the same operation in input will result in the same operation in output? How can we be sure of that? What is the thing that makes us sure that you're right, you're not wrong, but what is the thing that makes us sure that when we are adding in input, the output will also get added? What is that property called? That if we add the inputs, the resultant output will be the addition of the constituent out, outputs. It's linearity. That is the definition of
Linearity.
linearity, right? Linearity is composed of two principles. One is homogeneity, that you have seen, like you can take the C outside like that. And another is additivity, that you can add. So here you see you are given two different inputs, x1t as e to the power j2t, and another is x2t which is e to the power minus j2t. So by 2, this will give cos 2t. Now, as system is linear, so like if you just put a function over this, f of x1, f is, let's say f is the system, okay, so f marks the system. So as system is linear, so we can say like f of a x1 plus b x2. You can take a f of x1 plus b of f of x2. This is the definition of a linear function. So you can take the half outside, f of x1t plus f of x2t, half f of x2t. Now what is f of x1t? It is given that the output is e to the power j5t, and here the output is e to the power minus j5t. So half e to the power j5t, so this is nothing but cos 5t. Okay, so the answer is cos 5t. So that will conclude today's class. Thank you for attending. Next Tuesday again at 6 p.m. we will meet. Okay.
Thank you, sir. Thank you for
Uh,
giving information.